Hi, this is Heather from Melbourne in Australia.
Hi, this is Annie from Mountain View, California.
We worked together on our semester project and we chose to look at global warming.
Um, we have obtained a dataset from kaggle.com, and the datasets have been put together by Berkeley Earth, combining data, back from 1750 up to 2017, and they include 1.6 million temperature report. Um, Originally, we want to look at, like a more aggressive, like with the data set. But then, because of the data and the data set, the size is so big and the time is limited. So we end up with looking closely at 41 countries. So our findings may not be considered scientific, but we hope you agree. They are interesting and raise lots of questions and attention. So now Heather is going to talk us through some of our visualizations and what we discovered.
Right, we're going to have a look at some of the data that we've visualised onto a map of the world. We had to look through our data and examine and find the rate of change for each country, and that's what we've mapped here. So it's going from the ones that have increased the most, dark red, through the lighter reds, greys, and into the blues, the ones that have changed the least. So we can quickly see that it's very much Northern Hemisphere countries that have changed a lot, and colder countries like Canada, Greenland, Russia, also Mongolia and Kazakhstan and Finland. There's a couple of interesting outliers here. Iran is in the Middle East, and yes, it has cold areas but also very hot areas. And Niger is in Africa, and I imagine it's a very hot country, and its rate of temperature change is not only higher, fairly high, but also higher than the countries around it. One thing that does stand out, looking a bit odd, or there's two actually, is Alaska, but it's considered to be part of the United States as a whole. So I think that's just the influence of the measurements from the whole of the United States have kept the overall average down, or the average rate of increase down. And Iceland sort of stands out, but I guess we can only speculate, but it's probably to do with the fact that it is surrounded by the ocean. And as we haven't shown you yet, but as we've seen separately, the land and ocean global average has increased at a slower rate than the land as a whole. So on the next slide, we've got the countries, the top 10 countries by rate of change, and they're coloured here by their population. So the darker the colour, the more populous the country. We wondered in the beginning if population actually influenced how much temperature had increased. We've come to the conclusion that it didn't, but we just thought we'd show it here on these couple of bar graphs. Because Greenland is the smallest country that we looked at, only 56,000 people, and yet it's the third highest by rate of change. There's lots more to explore here, but unfortunately we don't have time for that. But if you'd like to look further at these, our maps and other visualizations, you can find them by following this link.
When we design, we bear the design principles and the visualization perception in mind, as we learned in our class. One of the example is at beginning of our design, we use a red green color for our map visualization in terms of temperature change, and then then we decide to change to red blue diverging colors, because we consider the red green color blindness, to avoid that, and also the red blue color is more compiling to users hot cold temperature convention.
One of the first things we did was to visualize the increase in global land average temperatures and global land and ocean average temperatures on line graphs. And this is what you can see here. And we can see that it looks like there's an increase on the land temperatures, but it's a bit harder to see anything really changing on the land and ocean temperatures. The Tableau allows you to display graphs like this with or without the zero included in the scale. So we changed it to no zero, and immediately we get a much more compelling picture. And now it looks like the land and ocean temperature is actually increasing at a faster rate just by looking at the trend line. But that's not actually the case. We realised that what we needed to do was make sure that the scale on the side actually was equivalent to each other. So you can see here that the land and ocean only covers the space of the number of 1, whereas this one covers 2, from 7.5 to 9.5. So when we adjusted the scales, we still got compelling visualizations that do show an increase, but we know that the scales are in fact comparable with each other and more meaningful, and so it actually agrees and is truthful in showing that the rate of change here, 0.5486, is lower than the rate of change here, 0.00865. The data sets we had really were enormous, and it was quite challenging to get them into a form that we could really work with.
There was a lot of cutting and pasting from Excel to organize the data by country in a way that was useful in Tableau. Then lots of manual transcribing to get the rate of changing data month by month for the different countries. Heather will show us some of the interesting things we found when looking at different countries.
Thanks, Annie. What we're looking at here is the global average temperatures by country broken down into months for some different countries. This page here has got Greenland. I might just get rid of all the months and then we can look at them month by month. So we can see January. We look here, we get the trend line, and we can see it was increasing at a rate of 0.01806. If we go down to June, add that in, which will be a warmer temperature, and it's increasing at a slightly slower rate, 0.00722. We could look at October, that'll be in between, 0.00852 Celsius per year. So what we had to do to look at the seasonal variation was actually transcribe all these figures for the various countries. So it's just illustrating the challenge of this large data set. We also found some interesting things just looking at these countries. You'll see here when we look at all the months, much more jagged lines in the colder months than in the warmer months. And we found that repeated in Canada, in Russia, and also in Kazakhstan. Of course, when we went to a tropical country like Indonesia, the months are much, much closer together because the average temperature doesn't change so much throughout the year, so it really does look like quite a mess. Here it is for the United States. You still see that kind of variation where it is a more settled temperature in the warmer months of the year and more variation in the colder months over time. Whereas Australia, where I'm from, seems to have lots of changes throughout all the months. There's no real pattern to that.
From what we visualize, we observe that global warming is real. It is more apparent in countries that are closer to the North Pole, and in colder Northern Hemisphere countries, winters are warming at a faster rate than summers. But there are temperature increases in every month.
We also had a great time collaborating across the globe. We're 12,500 kilometres or nearly 8,000 miles apart and 17 hours difference in time. But we connected and worked together. We hope you have enjoyed our presentation.
And thank you for watching our video, and hope global warming is an interesting topic for you too.
Thanks, Annie. Bye.
Thanks. Bye, Heather.
And if you're interested, you can look at all the Tableau visualizations that we've shared with you here in more detail yourself by following this link.